Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting to you the shining light on elemental mysteries, atomic absorption spectroscopy.
Introduce to you the mastermind behind our product. What is the product? It is an open access flipbook. Why? Because we can access the content everywhere on the internet. Also, the infographics provide short notes and keywords that make you understand better, or else you can self-learn through word search, word cross and quizzes. What can you learn from this flipbook? Let's get through this together with us.
Our teaching today will be highlighted on 5 topics about atomic absorption spectroscopy. First, the background. Second, you will learn about the theory and principles. Next, its component, the product's operation, and lastly, their application in the industry. Atomic absorption spectroscopy is an analytical technique used to determine how much certain elements are in a sample. It measures the amount of light at a resonant wavelength which is absorbed as the light passes through a cloud of atoms. As the number of atoms in light bulb increases, the amount of light absorbed also increases. The Beers-Lambert law describes the relationship between the light absorption and element concentration. According to the law, the amount of light energy is proportional to the number of atoms excited from the ground state in the flame.
Atomic absorption spectroscopy (AAS) is a technique used to determine the concentration of specific element in a sample by measuring the absorption of characteristic wavelength of light. It relies on the principle that atoms absorb light at specific wavelength, which correspond to transition between energy levels. By measuring the absorption of light by atoms in a sample, the concentration of the element of interest can be quantified. Atomic absorption spectroscopy (AAS) works on the principle that atoms absorb light at specific wavelength, which correspond to transition between energy levels. When a sample containing the element interest is vaporized and exposed to light of a particular wavelength, the atoms in the sample absorb energy and transition to higher energy level.
There are 5 components of AAS, which is the first one is light source, and then we have nebulizer, and then we have atomizer, and we have monochromator, and lastly we have detector. HCl, which is holocated lamp, is the most used as light sources in AAS, and it contains anode and cathode. Nebulizer will suck up liquid samples and mix the aerosol and fuel to create flames. Next is atomizer, where it separates particles into individual molecules and breaking molecules into atoms, and it has 2 types of atomizer, which is flame atomizers and graphite tube atomizers. Next is monochromator, which is used to select the specific wavelength of light, which is then absorbed by the sample. Last but not least, we have detector, which convert the light signal into an electrical signal.
Now, let's take a look how atomic absorption spectroscopy works. The process begins with the holocathode lamp HCl as the radiation source. Then the emitted light from the HCl passes through an optical chopper. It chops the continuous light beam into pulse. Flame containing the characteristic wavelengths of the element of interest proceeds to the next stage. Flame interacts with the sample under analysis. If the sample contains the element of interest, it absorbs some of the light at specific wavelengths. After passing through the sample, the light beam or flame exits through an exit slit. The selected wavelength then entered a monochromator. Within the monochromator, a convex lens may be used to focus the selected wavelengths of light onto a prism. The dispersed light is then directed onto a photodetector. The photodetector detects the change in light intensity caused by the absorption of light by the sample.
There are several types of application for atomic absorption spectroscopy, such as industry, heavy metals, medications, products, goals, and drinking water. Atomic absorption spectroscopy, also known as AAS, was widely used in the industries such as gold, mining, environmental control, and medications. AAS was used to detect heavy metals in a certain area so that it can be kept far away from as possible. For the medications, AAS was used to handle the quality of the medications to guarantee it is free from any catalyst. Next, business companies also use AAS to make sure that their products are safe to use. Furthermore, the amount of gold can be measured with the use of AAS to make sure that it was profitable or not. Lastly, the most significant use of AAS is the study of drinking water, particularly in areas where environmental conditions are not adequately maintained.